Hello, Form 2 students. Welcome to our mathematics lesson. And today we continue with our topic, surface area. Today we'll look at the surface area of a cone and the surface area of a sphere. I'm your teacher, Mr. Wanyoike from Medihill Girls High School. You're welcome. The surface area of a cone. To understand the surface area of a cone, we need to get the neck of a cone. And the diagram here, the green one is now the cone, and then the net is the pink one, and it is made up of a sector of a circle and a circular part or the base. The base is a circle, and therefore for us to get the surface area, we need to say the area of the circle, which is the base, which is pi r squared, and then we have the curved surface area that is formed from the sector of a circle, which is found by getting pi r l. In this case, the total surface area then will be surface area equals pi r squared plus pi rl, where pi r squared is the base, which is circular, and the curved surface, the area of that is given by pi rl. We'll be looking at the r and the l we are referring to in the next page. Lana, we have said that to get the surface area of a cone, we need to say it is pi r squared, which is the base, plus the curved surface area, which is given by pi rl. If you look at the parts of a cone, as shown in the first diagram, we have the red line that is running vertically to the center of the base. That one is called the altitude or the height. Then below that line where you have the base, we have the radius of that circle because the base is circular. And then for the curved surface area, for it to curve, the curved area is meeting at the vertex, and the line running from the vertex to the outer of the circle at the base is called the slant height. The slant height. The slant height is when we are calling the L. The L. So we have the height, h, the radius, and the slant height, and the vertex. And then beside this diagram, we have the net, where we have the base with the radius r. This is the r that we are referring to, the radius of the base. And then the slant height forms the radius of the bigger circle from which the curved surface was formed from. Remember we said this curved surface formed from a larger circle that is a sector. So the radius of that circle that forms the cone, the curved surface of the cone, is the L. And then we have the 2 pi r. The 2 pi r is actually pi d, the circumference of the circle at the base with the radius r. Therefore, r represents the radius of the circle at the base. L represents the cone's slant height. The cone's slant height. We'll look at several examples that will help us understand more. In an effort to understand a cone, let's use these two diagrams where one has measurements, the other has the labeling. And the first one, we have the height, which is shown in red on the second one, which is 40 units. Then we also have the slant height as 41. And because when we are looking for the surface area, we'll need the radius, then we must see the right-angled triangle running from the vertex to the center of the base, and the radius r, we can find r by using the 40 and the 41 because those two are part of a right-angled triangle, and therefore we can use Pythagoras theorem to get the radius. Once we get the radius of the base, then we can use the formula pi RL plus pi R squared to get the surface area of this cone. Learner, you can attempt it. Learner, let us look at an example here where you're told to find the surface area of the closed cone below. The first step, because we are given the perpendicular height and the radius, but we don't have the slant height. The first step is to calculate the length of the slant height. And we know that the apex, the line that runs from the apex to the base, and then from the base to the edges of this, the circular base, then that is the radius, then that forms a right angled triangle. And therefore, we can say L squared, which is the hypotenuse, is equal to 6.7 squared plus 10.2 squared. In this case, L squared will be equal to 44.89 plus 104.04, which would give you L squared as 148.93, and we get the square root of that to get L as 12.2 centimeters. From there now, we can use our formula that the surface area is given by pi r squared plus pi rl. In this case, the surface area will be pi times 6.7 squared plus pi times 6.7 into 12.2. And finally, that will give you the total surface area of this cone as 397.62 centimeters squared. 397.62 centimeters squared. Example 2, you are told to find the surface area of the cone shown in the diagram. It has a slant height of 16 centimeters and the base radius of 4 centimeters. So in this case, we just apply the formula, which is area is equal to pi RL plus pi r squared, that is the base. And you find that for the pi RL, that is the radius times slope times the pi, then that is 3.14 times 4 times 16, and that gives you the area of the curved surface as 200.96 centimeters squared. The base is circular, and therefore the area is pi r squared, which will be given by 3.14 times 4 the radius times 4 the radius, and that gives you the base radius as 50.24. And therefore, the total surface area is 200.96 plus 50.24, which will give you the total surface area as 251.2 centimeters squared. 251.2 centimeters squared. Learner, let us now look at the surface area of a sphere. I'm sure you have come across fruits that looks like spherical balls, or a representation of the earth, oranges, and so on. In this sector, or in this part, we'll be discussing how to get the area of a sphere. The area of a sphere is given by 4 pi r squared. 4 pi r squared. If it is half of it, which is we call a hemisphere, it will be a half times 4 pi r squared, or when you simplify that, you get 2 pi r squared. So for a hemisphere, it is 2 pi r squared. We'll look at several examples to help us understand more how to get the surface area of a sphere. Example 1, you're told to find the surface area of the sphere shown in the diagram. The sphere has a radius of 7. We have said the formula for getting the surface area of a sphere is 4 pi r squared. And in this case, the radius is 7. So we say it is 4 pi times 7 squared, which will be 196 pi, or 615.75. So you say the surface area of this sphere is 615.75 centimeters squared. 615.75 centimeters squared. We can look at another example. The surface area of a sphere we have seen is given by 4 pi r squared. So a sphere with a radius of 5 will give us 4 times pi times r squared, which is 4 times 3.14 times 5 squared, which is 25. That will give you the surface area of this sphere as 314.16 centimeters squared. 314.16 centimeters squared, corrected to decimal places. Let us now look at the surface area of a hemisphere. A hemisphere is half of a sphere. You are told to find, number one, the curved surface area of this diagram, whose radius is 21. And number two, you're supposed to get the total surface area of the hemisphere. Now in Roman 1, the curved surface area will say it is a half times 4 pi r squared. A half times 4 pi r squared, which when you simplify, you get that the area of the curved surface area of this hemisphere will be 2 pi r squared. Remember, our pi is 22 over 7 and the radius in this case is 21. So the curved surface area of this hemisphere will be 2 times 22 over 7 times 21 times 21, which will give you 2,772 centimeters squared. 2,772 centimeters squared. For Roman 2, where we have the total surface area, then we'll say it is the curved surface area, which is half into 4 pi r squared plus the area of the top in this case, which is circular, and the area of a circle is pi r squared. So in this case, when you simplify, a half 4 pi r is 2 pi r squared, and then we have the area of the top as pi r squared. So in this case, the total surface area will be 2 times 22 over 7 times 21 times 21 plus 22 over 7 times 21 times 21, which will give you 2,772 plus 1,386 centimeters squared, giving us a total of 4,158 centimeters squared. 4,158 centimeters squared. Let us look at example 4. We are told that a hemisphere, a hemispherical ball, is made of steel 0.25 centimeters thick. The inner radius of the ball is 5 centimeters. Find the outer curved surface area of this ball. Find the outer curved surface area of this ball. So there is illustration here, or the ball is here within a radius of 5 centimeters, and the thickness of this ball, or the steel that makes this ball, is 0.25 centimeters, meaning that we can get the outer radius as the inner radius plus thickness, which is 5 plus 0.25 centimeters. That will give you 5.25 centimeters. Therefore, the outer curved surface area will be given by twice pi r squared. Remember, this one is coming from a half 4 pi r squared, and therefore in this case the outer curved surface is 2 pi r squared. So it is 2 times 22 over 7 times 5.25 times 5.25. This 5.25 is actually the radius of the outer curve, or the outer circle. So when you evaluate that, you get that the curved surface area in this case is 173.25 centimeters squared. 173.25 centimeters squared. Remember, that is just the outer. Sometimes you can be asked to give the inner, would have used the radius of 5, or sometimes we need the surface area of both the inner and the outer. Remember, the thickness forms a ring that we need to get the surface area about, which is the larger circular part minus the area of the smaller circular part. Lana, we have come to the end of our lesson today, and here we have some assignment for you. You're told to find the surface area of each of the following shapes. So we have 4 of them. Do the questions diligently and carefully. If you need to go back to the lesson, you can always play back and then ensure that you capture every detail that we have covered in this lesson to enable you answer the questions in this exercise. Upload your work to Google Classroom and do it on time. In case you need more help on these lessons or others or any other help, then you can contact the next page and you'll be assisted. Have a blessed day.